Question 10 is quite tricky because you need to be able to look at a graph of velocity and understand what's going on. So we've got the graph of the velocity here of a particle that's moving along a straight line, and we need to describe what's happening at point A. Now, before we even look at the options and consider them, let's just try and tell a story here with this graph. Now, if a particle is moving along a straight line, we could either choose to imagine it going up and down, like a bouncing ball perhaps, or we could choose to imagine it going left and right along a number line, where the origin is 0. Now, we can see here that we're graphing velocity. So all down here, we've got negative velocity values, and up here, the velocity is positive. Now, what does negative velocity really mean? It means that you're traveling in a backwards direction. So if it's a number line, you could be traveling in towards the negative numbers, or if it's a bouncing ball, say, then it's going down at that point. So whichever way you choose to imagine it, you need to imagine that we're going backwards at this point here and forwards at this point here. Or if you're imagining that bouncing ball, then you'd say that in this section of the curve, the ball is headed downwards, and in this section, the ball is traveling upwards. Now, the next thing to think about is what's going on here and here. Well, at those points, the velocity is 0, isn't it? So that means that it's got no speed. The particle is stopped. Now, when you've got a particle moving back and forth along a number line, or a ball going up and down, when does it stop? What's actually going on when it's stopped? Well, with a ball, it's stopped just for a moment when it's at its high point before it starts to come down, and it's stopped just for a moment when it's on the ground about to bounce up. And for that particle on the number line, it's stopped just for a moment when it gets to the furthest place it's going to get to, and it stops to turn around and come back the other way. So in the beginning of this experiment, the particle was still. It travelled in a negative direction for a while, and then it was still again. So it must have turned around. Now it's travelling in a positive direction because velocity is positive. So what's happening here? Well, the velocity isn't changing, is it? We can see here that the velocity is negative, and it's getting more negative, isn't it? At every single microsecond that goes by, the velocity is going down and down and down. Here, for a moment, the velocity is actually at a stationary point. So it's a stationary point, but we're graphing velocity, and that means that the velocity is stationary. That means that it's neither speeding up nor slowing down. The velocity, just for a microsecond there, is not changing. Then the velocity starts to get more and more and more. It's still negative, but it's getting to be a bigger number. So perhaps it's, minus 0.8, minus 0.7, minus 0.6, etc. And then it's going the other way. So looking here, I can see that I've already considered the idea that it's not speeding up or slowing down. So I'm thinking that this is my answer, but I need to just check the others, make sure that they're not correct. So the object is at its furthest point from the origin. Well, what do we know about particles when they're at their furthest point from the origin? That is the time that they are going to turn around. And when they turn around, they're stopped just for a moment, aren't they? So velocity would be 0 at that time. And clearly at A, the velocity isn't 0 because those points have the velocity of 0. So we can discount that one. Acceleration is negative. Well, acceleration is the first derivative of velocity, isn't it? And so in other words, acceleration would be the gradient anywhere here. Now, what's the gradient at A? It's actually 0. So that would tell me that the acceleration at that moment is 0, which makes sense. If you're not if you're not speeding up or slowing down, then you're not accelerating or decelerating. So no, that's wrong because the acceleration at point A would be 0. And last one here to consider, the object is stationary. Well, no, it's stationary when the velocity is 0, and that's happening here and here. So that one can't be right either. And we've got our answer, D.